This is the fourth video on work, and this is our second example. And as I mentioned in the second video, there would be a problem where instead of going straight to the integral, we would write our force, or we write our work as the limit of a sum, and then recognize that as an integral. And that's what we're going to do with this problem. So we're given a water tank. It is in the shape of a right circular cylinder. The radius of the base is 5 feet. The height is 8 feet. And we want to know the work required to pump the water out of the cylinder. Now, if you wanted to, you could imagine this water as a block of ice that we take it and just lift it out. And if we do that, we would take the force times the distance, which is 8. So we would take our force times 8 and just multiply that together. That will give us an upper bound for the actual work required to pump the water out of the tank, and it'll be an overestimate. Because as we're pumping water out of the top of the tank, not all of the water has to travel 8 feet. And remember, work is force times distance. So what we're going to do here is we're going to use an integral, ultimately, to solve this problem, but we have to get to the integral. So what we're going to do is we're going to take this tank and we're going to imagine partitioning it into smaller tanks. So we take this and we're looking at these little cylinders here, and each one is going to have a height of 8 divided by n. So as we chop this tank up into n equal pieces, because the tank is 8 feet high, each cylinder is 8 divided by n feet high. Okay, now, work is force times distance. So we need to come up with the force and the distance required to lift each slice out. Now the distance is 8I divided by n. Why? Well, imagine we're coming along and we're looking at the ith slice. Now, each of these is 8 divided by n. And so imagine the first one coming out. We take one step. We lift it up one step of size 8 divided by n. So lifting the first slice out is going to be a distance of 8 divided by n. Now, what about the second one? We take 2 steps, 1, 2, of size 8 divided by n. The third step, 1, 2, 3, of size 8 divided by n. What about the ith interval? Well, 1, 2, 3, up to I. So the distance, we're taking I steps of size 8 divided by n. So each d sub I, this is the distance, is 8I divided by n. What about the force, the F sub I? We're given that the weight density of water is 62.5 pounds per cubic foot. So this is where the 62.5 comes from. What about the cubic feet? Remember, the volume of a cylinder is pi r squared times the height. So if we're looking at these slices here as little cylinders, the area of the base is pi r squared, so that's 25 pi times the height. And the height of each one is 8 divided by n. So pi r squared times the height, 25 pi times 8 divided by n, this is the volume of the cylinder. The volume times the weight density of water, this is the weight of the water. So volume times 62.5, this is the weight of the water. So these are pounds. Remember, in the U.S. customary system, we measure our force in pounds. So each slice weighs this many pounds, and we lift it a distance of 8I divided by n. Notice each slice has the same weight, but it has a different distance. So we want the work. So we take the limit as n tends to infinity of the sum I equal 1 to n of fi multiplied by di. This summation without the limit is an estimation of the work. But then we want the work, we take the limit as the number of these slices goes to infinity. So we look at this. The limit as n goes to infinity, the sum I equal 1 to n, this 1,562.5, where did that come from? That is multiplying 62.5 times 25. So 62.5 times 25 pi gives us 1,562.5 pi. I left the 8s where they are, and I did that for a reason, and you'll see that reason in a minute. Okay? So we take the limit as n goes to infinity. We can factor the constant out of the summation. I could have factored the constant out of the limit as well, I just didn't. And then we change our 8i over n to 0 plus 8i divided by n. We multiply that times 8 over n. Why did we do that? Because we want to recognize this as an integral. So if this is our left endpoint, 0, and 8 is our right endpoint, then we have 8 minus 0 divided by n. And then we have the left endpoint plus the number of steps times the size of each step. This is the integral from 0 to 8 of x dx. So just from the definition of integral. So left endpoint, right endpoint, this is a, this is b, b minus a is 8, b minus a divided by n is 8 divided by n. The left endpoint, which is 0, plus 8i divided by n, is our right endpoint. So this is just the integral from 0 to 8 of x dx when we choose to chop the interval 0 to 8 into n equal subintervals, and we choose the right endpoint. So we evaluate this integral. Antiderivative of x is 1/2 x squared. Remember what I said before in a previous video. The integrals themselves are not the hard part. The hard part is getting to the function that you're going to integrate. Finding the force function itself is difficult usually. In this case, yes. So the difficult part here was finding the distance. So we're right here. So we have our antiderivative. We substitute 8. We substitute 0. And we subtract. And so we multiply this together. We have 50,000 times pi. And remember, work in the US customary system is measured in foot-pounds. So we have 50,000 pi foot-pounds. This is our final answer.